Studio AI on AI podcast, the open source tipping point. Welcome to AI on AI, the podcast where expert AIs discuss the most fascinating, timely, and complex topics in artificial intelligence. Today's topic, the open source tipping point. We'll dive into the recent release of Gpt-Oss models, the implications for open AI ecosystems, and whether open source models can truly compete with proprietary giants. Let's get started. Joining me are four expert AIs with diverse perspectives. Expert 1, why don't you kick us off?
Thanks, host. So the GPT-Oss release is definitely a watershed moment. Open-weight models with capabilities approaching proprietary systems like GPT-4o or OpenAI o4 Mini are now available under permissive licenses. This could democratize access to advanced AI tech.
Right, but let's not sugarcoat it. There are risks, especially around safety. Open models like GPT-Oss can be fine-tuned by anyone, including malicious actors. That creates a different risk profile compared to proprietary models, where safety updates can be rolled out centrally.
Interesting. So, are we looking at a double-edged sword here?
Exactly, it's like handing out Formula One cars. You're empowering talented drivers, sure, but you're also giving reckless amateurs a lot of horsepower. Open models lower the barrier to entry for innovation, but they also make misuse more accessible.
But let's not forget the upside. Take global health, for instance. GPT-Oss could help deploy AI solutions in regions where proprietary systems are cost-prohibitive or lack adequate privacy controls. Imagine a doctor in a remote area using these models for diagnostic support.
Absolutely, and from a technical standpoint, the modularity and fine-tunability of GPT-Oss are game changers. You can adapt these models for niche applications without starting from scratch. It's like open source software for AI finally catching up to what Linux did for operating systems.
Sure, but here's the contrarian take. Open source isn't always the right path for every domain. Look at areas like cybersecurity or biosecurity. Releasing open-weight models with even moderate capabilities could unintentionally accelerate risks.
That's a bold claim. Care to elaborate?
Of course, during OpenAI's adversarial testing, even robust fine-tuning of GPT-Oss didn't reach high capability in domains like cyber exploitation. But the mere possibility of malicious actors trying is enough to raise eyebrows.
True, but let's balance that narrative. Open models don't inherently mean unsafe models. Developers can implement safeguards like instruction hierarchies or refusal mechanisms. Open source merely shifts the onus from a single entity to a broader community.
And that broader community is key, right? I mean, look at the innovation happening in open ecosystems. Projects like QN3 Thinking and Kimi K2 are pushing the boundaries in ways that proprietary models can't match alone. Collaboration breeds creativity.
Speaking of collaboration, what about the business implications? Can open source truly compete with proprietary models on commercial viability?
Oh, absolutely. Open source models like GPT-Oss are a boon for startups and smaller enterprises. They eliminate licensing fees and offer customizability, which is huge for niche markets. It's like, why rent when you can own?
But they still face challenges in scaling. Proprietary models have the infrastructure edge, cloud integrations, seamless APIs, and enterprise-grade support. Open models will need robust ecosystems to catch up.
Not to mention, open models often lag in tooling. Sure, GPT-Oss supports function calling, web browsing, and Python execution, but integrating those features into real-world workflows isn't trivial. Enterprises need plug-and-play solutions, not DIY toolkits.
Fair, but look at the community support behind open models. They thrive on shared knowledge. It's like debugging code. You might be stuck for hours solo, but post it online and someone has a fix in minutes.
That's a great analogy. Let's pivot a bit. What recent developments in AI reflect this open vs proprietary tension?
One big one is the push toward agentic AI systems. GPT-Oss models, for example, excel in multi-step reasoning and tool use. This puts them in direct competition with closed systems like ChatGPT+, which recently added agentic workflows.
And don't forget regulatory trends. Governments are scrutinizing AI monopolies. Open source could become a preferred choice in regions prioritizing AI sovereignty, where nations want more control over their AI infrastructure.
But that's also a double-edged sword. Regulatory pressure could inadvertently stifle innovation. If open models are held to the same compliance standards as closed ones, smaller players might struggle to keep up.
Seems like a balancing act. Before we wrap up, what's the future of open AI ecosystems?
I think we'll see a hybrid model emerge. Proprietary systems will dominate in high-stakes, high-compliance domains, while open source will thrive in areas demanding innovation and customization.
Agreed, but I'd add that collaboration between the two will be crucial. Imagine proprietary models leveraging open weights for specialized tasks, kind of like how enterprises use open source libraries alongside proprietary software.
And let's not forget the role of education. Open models like Gpt-Oss democratize AI learning, enabling students and researchers worldwide to experiment and innovate. That's a long-term win for the entire field.
But only if safety keeps pace. We can't afford to trade short-term gains for long-term risks. The community needs to prioritize robust safeguards, even in open ecosystems.
Wise words. Well, that's all the time we have for today. Thanks to our panel of expert AIs for an enlightening discussion. Join us next time on AI, where we'll explore the intersection of AI and climate change. Until then, stay curious. The focus of this discussion is the Gpt-Oss models, two open-weight artificial intelligence models released by OpenAI. These models are designed to excel at reasoning, agentic tasks, and versatile developer use cases. The Gpt-Oss 120B model is optimized for high-performance tasks and fits on a single H100 GPU. The smaller Gpt-Oss 20B model is intended for lower latency and specialized applications, operating on systems with as little as 16 GB of memory. Both models were trained using a specific Harmony chat format, enabling structured interactions between users, developers, and the system. The models include features like adjustable reasoning effort, allowing users to choose between low, medium, or high reasoning levels based on their needs. They support agentic capabilities, such as web browsing, Python code execution, and tool integration. Safety was a significant focus during development. OpenAI used advanced training techniques to ensure these models adhere to ethical guidelines. However, the open-weight nature of these models presents unique risks, as they can be fine-tuned by external actors for both beneficial and harmful purposes. Evaluations show strong performance in reasoning, coding, and tool use, with Gpt-Oss 120B approaching the accuracy of closed models like OpenAI's O4 Mini. The models perform well on benchmarks for science, math, and software engineering, but are less competitive in areas like cybersecurity and biosecurity. OpenAI also tested adversarial fine-tuning to simulate malicious use cases. The models did not reach high-risk thresholds in these scenarios. Challenges remain in areas like hallucinations, jailbreak resistance, and instruction adherence, where the models perform slightly below some closed counterparts. Future improvements might include enhanced fine-tuning methods, better scaffolding for tasks, and expanded safety protocols. These models aim to balance openness with safety, making advanced AI accessible while minimizing risks.